Håkon Dybdahl. I am from Komoya. I'm here to present an open source project called Cloudname, which is implemented by Bjørn Borud and me. It's basically a library or a tool for coordinating services. If any of you have run a system with more than 50 machines, you know the pain of setting it up, configuration, how to resolve the different machines. So when I'm talking about cloud computing, I'm thinking about a lot of machines. It could be thousands. And I'm also thinking lots of services running on these machines, not a single service. And imagine that this grid is a logical view of the computers. And the traditional way of doing it might be like this. You put one instance of a service on one machine. You might even put a cute name on the machine, so you know what it is, what the machine is. But this is kind of wasting resources, because none of these machines might be fully utilized. So a better way to do it could be to fill up all the machines. If you have one application that requires a lot of CPU, you bond it with another application that requires more memory and less CPU, and then you utilize the full hardware. This is more complicated because now you suddenly are running two services on the same machine. Maybe the front-end server no longer responds to port 80. So you basically need some better resolving, port number, machine number. And also, when you start to increase and use more machines, the probability of failure increases. So you basically want a system that can handle failures. Oops. Let's try this one. There we are. So basically, if one machine dies, the system should reschedule your processes. And you shouldn't need to reconfigure all the machines that connect to this machine. And also, you should be able to launch new services, take them down, and also some of the instances might start to use more memory and you want to move it to another box, and this should be easy. So basically, could you use DNS for this? So just to recap, what is DNS? DNS is basically giving the machine a name. You have a name and you resolve it to IP address. That's a bit more simple than it actually is. And basically, if you have a computer, a client, and you want to go to an address, you look up the address in the DNS server, you figure out the IP address, and you go to the server. And you also get the time to live with this from the name server, basically saying that, okay, this IP address might be valid for a day. If you go to this same address again, within the day you can reuse the IP address. And this is fine. However, if you have a dynamic system, you don't want like a day or lifetime. You basically want updates. If a machine changes, you want it instantly. And you also, the problem with DNS is, if your machine dies, you cannot inform this client that the machine is dead. It's basically, it's not a very dynamic model. It's not based on pushing. You could set time to live to a very short time period, and then query the name server every second, but it will create a lot of load, and also it's up to the client to figure out what's going on. So Cloudname does this in a different way. So in this figure, you have A1 to A5. Imagine this is 5 instances of some service you're running. Your client only needs to connect to one and ask for whatever service it is. And in order to resolve this service, it's pretty much like DNS. You're asking the Cloudname server, where is this server I want to connect to? You get some address back and you connect. And then you can have a failure. This server might start to burn or crash or something. And what Cloudname gives you is basically, Cloudname discovers that this server is no longer working. It's taking the heartbeat of all these servers. And it informs the client to go to another server and it gives you the name of the server or IP address. In this way, you don't need to care about where is the other service running. You don't need to know the name of the computer. You don't care about anything. You basically get updates if it changes. And you can have several servers, and if one goes down and you're connected to it, you will get a message to which other server to go to. And you can also ask for all of them. So basically, just to recap what Cloudname is, it keeps track of your services, and it resolves more dynamically than DNS. And how does it work? So basically, a service has a coordinate. So when a service starts up, it says, I am 0 front-end production Oslo. It tells Cloudname this. And here we have 3 different servers. And then the client asks, I want to talk with any of those. And you just specify any, and I put web port here, because when you register a service, you also register what kind of service do you have. For example, a web server might have a web port, but you can also have a different service port, or you can have multiple ports, and you can name them. So any will give you one of those that is up and running, and if it dies, it will tell you to connect to a new one. And how does this look? I mean, is this very hard to use, or just to show you some code example. So this is the server. The server is what we call claiming the coordinate. It's basically saying, I am running this service, register me. And basically what you do is to create a coordinate, which is what we call the points. And in this case, 0 front-end production Oslo. And then you call Cloudname and you say claim. And basically, you're not guaranteed that you actually own this coordinate. You have to check afterwards. I didn't include that here just to keep it a bit simpler. But basically, if someone else has claimed this coordinate, you're not allowed to claim this. So there are some helping functions, for example, wait for claim OK, and so on. And if you look at the client side of this, it's basically there are different APIs. This is a dynamic API. Basically, what you do is to implement a listener interface. And then you will get events, and you put up a query, and then you get events whenever something happens. It might be that a new endpoint is available if the old one dies. And I mean, in this case, you have any, but you can have all. You can resolve a specific instance. You can also implement your own strategies. And if you want to, this is available. And you also made sort of what we call a code lab, so you can basically download the code and follow instructions, and then build a client and a server application, run it on your own computer, and see how it works. It should be pretty straightforward if you're interested. We're also using this project to build a bigger infrastructure project. So this is one building block in our system. And it's, yeah, do the code lab if you're interested. Any questions? No? Yeah? So the question is, can you use the load balancer instead? Or would it make sense? So basically, you can build a load balancer on top of this. So basically, you get a list of all available clients, and then you can do round robin. You can look at the queues. It's basically up to you. What we're planning on doing sometime in the future is to build a REST API load balancer on top of this. I think we will need that. It will be nice. Then you can have different strategies. If you build both the client and server side, I think it would be nice to, for example, respond with how many entries were before you in the queue on the server and stuff like that to get some nice strategies. But yeah, if you want to replace this with a load balancer, it's because you still have the config magic. It's hard to set up a service. It's hard to maintain this. Here you basically just type the coordinate of the server, and you don't care which machine it's running. And when you start to have a lot of services, this makes a lot of sense. Time is up.